greetings to you. Hi and thank you for your time. Yes, I'm just going to do a quick walkthrough of this lab, and I've got two sites. Yeah, so this is site number two, which is in EVNG, and if I go to site number one, is in Proxmox, is in my Proxmox server, and I have a few. If I just go directly on the website, yeah, yeah. So these are the virtual machine I have within my second site, and within the site I have my other site, which is EVNG. Now let's talk about this second site, I must say, which has a lot of networking going on. So basically, what's going on in this site is I've got two branches, and Tokyo being the headquarters, and of course Lagos being a branch office. Yeah, and in each of the sites there are multiple networks, and there's a lot that's gone into the networking because it's in a virtualized environment, and I've considered high availability, latency, jitters, and everything like that. So if I just do a quick review, and in this Tokyo branch I've got four VLANs, so that's the network is well segregated, and I have my users are in VLAN 10 and VLAN 20. If I just go into my PC, and of course we can see that I have yeah, by going to my switch, and I just say VLAN or show VLAN brief. See, I've got VLAN 10 to 30 at this point, and if I go to the PC at these distribution switches, we can see here that I've got other VLAN there, VLANs there as well, and of course, so at this section, distribution section, that's where I have the server operation going on the most. As you can see, I have multiple links connected, and in this link I'm using ether channel to actually bond the ports together. So okay, yeah, so the ports are bond together, and of course that's how they're able to the port aggregation helps in speeding up the network as well, because all the nodes you see here have access to the internet for real. So yeah, so the way it works is that this PC, the way it works is that I've got another router here, so that, and it's done so that when a device is down, when let's say take for instance this switch is down, take for instance, stop. It's expected that the device should be able to traverse through the internet from this access switch through this distribution switch, and to go through the firewall, yeah, to reach the internet. And if they have to go through the domain controller, which is this server here, then we can go through the server as well. And I have my MECM, or should I say SCCM here, endpoint configuration manager here as well, which communicates. And of course, that's for the headquarters, and I have WSA Security Alliance and Access Control CS here, and of course the point of them is strictly extensive networking, but I'm not talking about security at this point. But and here I have a Docker worker here, which of course I use for Linux operation because it helps to save resource, but I'm talking mainly about the networking at this point. So in terms of connecting this network, as you can see, I have an extension here to the LAN, and this is how I'm able to connect to my the some of my PCs in my second site in my Proxmox here. So now regarding the connection, because this PC, specifically, these two servers specifically are connected to the domain controller 1, because there's a lot of replication going on. When I'm talking about the server administration aspect, I'll go into detail about the bonding. But in terms of connection, this is quite direct to the site. However, in terms of connecting the end devices and the Docker workers to, you can see the Docker workers does not have any link directly to the ProXmox LAN. However, I've got two Docker managers here because I'm operating the Docker Swarm. So in terms of to allow the communication, I've built a tunnel that's gone through that routes the traffic through this through this firewall here to go through the internet. You can see these are proper clouds that are actually mapped to the PNet of my my physical network interface here. So that's how they are able to communicate, and the communication between these two sites as well is being done securely because I'm using IPSEC at this point. So without talking too much, if I just go straight into the firewall, you can see we have one firewall at this edge, we have another one at this edge as well. So if I go through my management PC, sorry about that. Okay, so here I am in my management PC, and I'm going to bring it to the site. So this is site 2, and here I have site 1. Now, the way the communication is being done is that this is my Docker manager, which of course is this Ubuntu PC that I'm using at the moment. So if I say host name, you can see this is my Docker manager 1, which is connected to my domain, is in my site number 1, and it's connected to my domain. If I do list, you can see it's connected to hybrid hub.local. So now the way this Docker manager is able to reach this Docker worker, as you can see I have a Docker worker 2 here. I have a Docker worker 2. If I just open the Docker worker 2 again, I have my devices well arranged there, and I say Docker worker 2, and I just do, it takes some time to, because it's going through a VPN and it takes some time, so it's taking time to resolve. If I just do Docker worker again, why is it Docker worker? Oh, sorry, Docker worker 1 is off. Is O2 that I have on at this point. So I'm gonna just go through Docker worker 02, and of course I should be I should be able to. So if I do IP address, you can see we have IP address. You can see we have 10.10.30.17. But how are we able to access this particular network from my Docker manager, which is which the default IP address is 172.16 in my site 1? That's because if I do nmcli connection show active, we can see that I've got two tunnel interfaces here. And if I just do cat, okay, if I do, okay, I'm in the folder. If I do ls in this folder, you can see I have my Tokyo Lagos certificate, and I have my Tokyo certificate as well. And this, I'm using Tokyo particularly at this point, so I'm connected to Tokyo. So if I do IPA, you can see that I've got an IP address within the subnet of 10.20.2.18, sorry, that connects to Tokyo, and this connects to Lagos. Sorry, this connects to Lagos, this connects to Tokyo. But let me just not talk without showing evidence. If I go straight into my my firewalls, and I open the firewall of Lagos, and I come again, I open the firewall of okay, I open Lagos now. So I have Tokyo open, I have Lagos open. I'm going to type my password. I have a very easy password because it's a lab and I can do what I want. Okay, yeah, so I'm inside of my firewall now, and if I go into status, it's a little bit slow because I have so many devices on. So if I go into status, I can just go and say OpenVPN And as you can see, I've got this virtual address IP address setup here. And of course, if you check my certificate, my OpenVPN certificate, you can see I have certificates pointing to because I have two Docker managers here. I've had to create two certificates, server certificate particularly, so that the Docker managers can actually communicate. When I'm doing Linux operation majorly, that's when it's more relevant, because I don't really use OpenVPN for Linux for Windows operation as much. But what connects the two sites is the IPSEC tunnel, which we have built, and that's what makes it interesting. So if you can see, we have a child interface here, and we are here as well with this we have child interface here as well. So if I disconnect this, you will see that this should status IPSEC, it should be disconnected as well now, because they are connected and could communicate. If I connect again, then they should be able to establish a connection established between the two sites, and that is how they are able to communicate on the two sides. And as you can see, we have multiple ISP as well in this case, and that is to say that we try to do some sort of reliability in the network here, and that is the point where brings us to the point of ISP load balancing. So I've got two gateway which are grouped together, and that is what you see that I'm using as my default gateway at this point. And of course, the interfaces, the gateways function independently, but because I'm operating a dual load balance gateway, so that's why I've got just a gateway there. And I have a gateway here as well, which is not grouped, and it is particularly connected to my the IPsec tunnel. As you can see, this is the gateway IP. This is the virtual IP address of the IPsec tunnels. And in terms of routing, everything about, because I have so many VLANs and so many subnets, most of the routing are being done via OSPF here, routed VTI. So if I just go into my OSPF, I show my status, OSPF neighbor. Yeah, you can see I have quite a number of neighbors. You can see this is a neighbor here is 777, and if I go to the other firewall router here, I go to the status FRR OSPF, you will see that here we have okay, here I've got 33, here I've got 33 connection to 333 as a neighbor. So if you look at the independent router ID of these servers, you will see that of this firewall, we will see that service OSPF, you see that this is the Lagos firewall is 7.7, that's the router ID, and this one is 3.3.3. that confirms their communication. And if I go to the status diagnostics, if I go further ahead to say I want to ping from Tokyo, let's assume that I just want to ping from host name to ping. Let's say I just want to ping 10 because we checked the IP address of the our Docker O2 that is in Lagos branch, and we see the IP address is 10.10.30.17. So if I go from my Tokyo browser and I say I'm pinging 10.10.30.17, I should be able to ping the interface successfully, as you can see, and the traffic is routed through the tunnel, of course. And yeah, that's basically about the connection between them. And in terms of the connection between the devices as well, as you can see, if I open this router here and I say show IP interface brief, you can see I have router on a stick formed here for the VLAN specifically. So that's to say that even though this particular switch is down, we can still access the internet through this router. However, if this router is down itself, we are still able to access through the switch, and if they are both on, we are still able to access, but I have to put one on at the same time to save my resource, because I don't want this lab to hang. So and that how they're able to communicate is because we're using virtual IP address. And of course, if I go into my firewall, I'm using my firewall to do the routing on this link. So these switches are just working as dumb layer 2 switches, not too much layer 3 operation, except for this link that connects to the router here. So if I go back to my Tokyo device and I go into my and I go to my firewall virtual IPs, you can see here at this point that we are using CARP. We are using CARP specifically for the virtual IP addresses for the interfaces as required. And if I go into the IP address, so if I go into the router and I say show VRRP, you can see that okay, this is a switch 2 or switch 3 is off. If I pull switch 3, if I pull router 3 back on and I just open it, it takes a little bit of time. Yeah, it's back on. I say show VRRP, and of course you can see my virtual IP addresses are there, and of course we have priorities set where necessary, particularly for VLAN 30 and 40. You can see priority here is 100. However, priority with the on the firewall interface, priority on the firewall for the this thing is 150. If I go to virtual IP, if let's say we check VLAN 30, you can see our priority for VLAN 30 here is 1, while on the switch is 100. So it varies independently like that. And aside from that one, this on the at the Lagos branch, okay, the server here, domain controller, is providing DHCP for this branch locally here. However, in Lagos, the the firewall provides the DHCP services to the branch. So if I go to status, we say status DHCP leases, you can see we have these IP addresses, of course, and for the Docker worker, which has the .30.17, the IP address is static. So if we go back into the service DHCP server and we go to 1000 VLAN 60, we'll see that the network starts from 20. Address pool starts from 20. So I've reserved 17, 18, and 19 for my server for our static allocation to the server. As you can see, we have two DNS server, which is the domain controller within the lab 1 here, and of course the domain controller within the second site itself. Now that is because these two domain controllers, the services are replicated. Okay, domain controller 02 is down at this point. If I just try to go back to it, and we'll see if it's back on or it's okay. Domain controller 02 seems to be down because it seems I have too many devices up now. So I will just my domain controller 01 is on. Domain controller 02, my MECM server is okay. If I just do a direct VNC opening, okay, my domain controller 02 is down. Okay, so I'm just gonna put on my okay, yeah, so I have to just do okay. So the cause of it being down is because in the lab environment, I've noticed that because if you look at the interface, if you look at the connection I have here, I have two connections to each of the sites, and the interfaces are teamed. Now, ideally, the interfaces are supposed to, shift and pick up the operation, but within EVNG, it so happens that when I switch off a PC and I want the other interface to actually take up the operation, even though I have the NICs teamed up. Now I'm operating teamed interfaces, and I have two of the interfaces are expected to be active at the same time, and all active at the same time. One is supposed to pick up the operation, but sometimes I have to put it off and put it back on before it picks up the operation the way it should. That's a lag within EVNG that I've noticed, but it really does not affect the operation of the lab. So now that we are back online, we can go back to my administrative PC and connect back to my domain controller O2, and I should be fine. So I can equally connect to my MECM server via VNC, or sometimes via RDP as well. So these are the end devices, which I'm just going to put them on off for now. And yeah, I'm just going to put the end devices off for now, and I'm going to talk about the formation of in terms of the router on the stick. I've spoken about that, and in terms of the link here, as you can see at this branch as well, I have a backup, what seems to be like a backup router as well, and these are Arista switches. Usually I put one off because they take a lot of memory, and so this router at this link, it has LAC. We're using LACP at this point just to bond the interface together to give it more load balance speed. So if I go to Lagos, if I go to my firewall in Lagos, then we'll see that in Lagos, if I go to my interfaces, we'll see that we have two links, VNet 2 and VNet 3. This is VNet 2 and 3, which has been grouped together, and they have been assigned an IP address like 0, and they have been assigned an IP address, and the interface is active. And if I go into my interfaces and I check the status of all the interface, you'll see that the interface like 0 is up, and it's up and is working effectively. And so because I'm saving resource, because if I put all the servers on at the same time, it's going to sometimes it tends to bring the lab down, especially when my MECM server starts to back up its operations, because the way the operation works with the MECM server is that I'm gonna have to dive into the administration at this point. Anyways, there's more to talk about in terms of the networking, and especially in terms of if I just go to the even the more interesting one, which is the setup of the networking within ProXmox. So if I just do okay, let me just use a PC that is clear. If I just SSH root at that should be 192.0.0.27 192.1.6. Sorry about that. It's 192.1.6a. Yes. Yeah, clear. If I just cat, this is my site O2 ProXmox. I've just SSH into it. If I just nano nano slash ed slash network slash interfaces. You can see I have a lot of network connections here, and these are to simulate real life situation. As you can see at this point, I have what seems to be like my second ISP, which is the 30.147, and I have my 20.147. At the same time, I have my this is the interface I use for my Docker and my storage. Of course, I didn't mention I have a storage I'm going to show very soon. And I have this ProXmox VM. I use it for my iSCSI storage for my SQL specifically, and I use this network for my domain operations. And of course, yeah, and I have my ISP router as actually that is my ISP network. So nothing, and I have a replica of the network because sometimes I tend to use Wi-Fi on my server, so I have a replication of this network so that I can easily just switch the network if I really have to without having to stress myself. And at the same time, even though the interfaces are primarily created, I have DHCP running on the I have DHCP running as well for the interfaces. And if I go to my lab now I'm going to talk about the administration of these site 01 and the PCs in site 02 and all this server. Okay, now so the way the operation goes is that I have mycv server here. Now before I talk about that one, I'm going to talk about how the operation is being done. So within the lab here, within the site here, I have my mycv server, and this mycv server is I have my in the site 01, I have two Windows Server PC. One is off at the moment, but if I go into the Windows Server PC, if I just go back again, I say my clustered PC node 01. As you can see, we are inside of node 01 now. Just going to do a quick logout here, sign out, because I like to use my VNC. I like to use my, what's it called? We're still picking up. mycv has a lot of glitch in endpoint administrator mycv. So it should pick up now after this time. So mycv has a lot of glitch anyways. So in the server, that's because I've popped down the memory. I'm using just one core CPU, and I think that's the main reason why the problem is happening. So I'm going to use a VNC for this lab. If I go into site 01 and I go into the nodes, and if we look at mycv, you can see I've assigned only one core. If I'm using two core, usually most of the time is fast, but I have to open a lot of PC for the sake of this lab. So now that we have the server, so now that we have that, I'm going to talk about the clustered node 02. This is a clustered node, and only one is operating at this time just to save memory. And if I go into my failover cluster manager, you can see I've got three services. One is my SQL, and if I go into my SQL Studio, you can see I have my AD Connect, which of course the entire lab is called Hybrid Hub. Yes, so it's more like I'm using AD Connect. I'm using Intune as well with all the operations, which I'm going to talk about over time. Yeah. And my mycv database is here, and my WSource database is here as well. So they're connecting remotely to my mycv in my site 02. my site O2, and of course I have IIS server, but I've stopped the IIS server because it's irrelevant at this point, because I've transferred all my, because it was taking too much memory, so I've had to transfer my website operations into Docker. So if I do clear and I do docker ps, you can see I have my Docker running. And of course if I just do if I do Docker, just not gonna waste time. If I do Docker exec, it takes me to the, oh sorry, clear. Okay, if I do Docker exec, it takes me into the PowerShell of the Docker. And if I do if I do ls to list the directory, I cd into inet, and I cd into, and I do ls cd into www roots ls. You can see my website files here. And if I go into if I exit, you can see my Docker is running. I do ipconfig, you can see that I've got my IP address, but my interface is that is bind to my website running in IIS Docker is on this interface really. So if I go into my browser on my management PC, I can easily just, I've mapped this. If I go to my domain controller, you will see that domain controller DNS, sorry about that, DNS. If I go to my mycv.local, you can see I've mapped this IP address. This IP address is actually assigned to my okay, it's not particularly mapped, but I've mapped it on my I've mapped this IP address specifically on my PC. If I do cat /etc//host, you can see this is mapped to, I mapped it clear. Okay, my DNS should be replicating. If I do DNS host name a record, and of course I think I mapped it at some point. Cat /hosts 192, just IB.local. This is maps, and I mapped it to a particular DNS because I was doing the caching. But anyways, if I just do 172.16.10.4.10. No, that was .10.4. Then it should bring me to my CV website. And if I go into another PC, if I just remap this server, I map the inside, and yeah, if I just create another zone, new a record was created already. Oh yeah, it's mapped. The name of course is mapped already. So if I do, I was expecting something else, but I get already. So it's my mycv.local, and as you can see, if I just go to my PC and I type mycv.local, it brings me to my CV, of course. And as I'm not the best person with web design, but I've only done the design I can do at this time. So I have a few that says about me, my award I got from my school, my education, my skills, which of course I'm still working on, and my experiences. I've got my portfolio that linked to my GitHub. As you can see, if you come to my GitHub, you can see my scripts I've created, and several project I've done right from time. It's particularly the network automation and abstraction. I have a bunch of have a bunch of scripts here that makes my operation comes into play and everything. So that's they link to the relevant directory, but that's not the point of this conversation. I was talking about the SQL server. So my CV is running in Docker, as you can see already. So Docker PS again, you see the Docker is running, and that's why I've had to stop the IIS server here, because to save memory. And of course, I've got Hyper-V as well. I have Docker Manager running inside of Hyper-V, but it's off at this point as well to save resource. And I have my SQL server running, which is linked to my MECM, at this point, so I can always switch on my server. And of course, my MECM has a lot of operation going on. So if I just close some of these devices and I go into my okay, I'm inside my MECM now, waiting for the config manager to load up. And once it's loaded, if I go into my devices, you'll see I have my devices listed, a lot of them. And now ideally, because my devices, if I go to my site 01, you can see I have my Tokyo 10 PC, Windows 10 and Windows 11 PC on. Ideally the green light should be on here, but because I've noticed whenever I pop the memory down to one CPU, it tends to lag and gives me a lot of some kind of trouble, but it's still gonna work. So if I just right click on my device, if I just, okay, let's say the device is working now, is on, and I can easily just go into my, close this one and easily go into my management workstation and select let's say Lagos, and of course it brings me to Lagos PC. Very easy. I don't really have to go into the site anyways. So now the way it works is that now to confirm the operation and the connection with PC, if I just right click and I say start remote control, I should be able to connect into the remote section, and we should, okay, asking remote. If I go back, then I'm gonna have to approve the remote section request, and I should be able to be able to access my PC within my MECM. And of course I have some applications deployed already, which are made available to the users. It's taking some time, but yeah, we have internet connection on the device, and if it's taking some time, then we just check the Tokyo 10 PC, which should be okay, a little bit faster. I've popped all the resources there. Okay, yeah, this one is a little bit faster, and I've got my resource, my applications. If I go back to Tokyo, you can see that the applications are here as well. The Windows 11 applications are here as well. And in my hand devices, I've deployed, I've remotely installed the Office 365, which is effectively working. And of course, I can easily just demonstrate and install here. That installs, come on, it's quite slow. That install, let's say I want to install my 7-zip, can easily just install 7-zip. And if I go back to my folder here, my PC is still loading, is installing at the moment. So failed to install. That's because there's a lot of lag going on. If I just put down one device, install. If I put down a device, it's going to be a little bit faster. So I'm just going to put down the Windows 11 PC, shut down, and we should be fine. And this one is working, is operating. And of course, at the same time, I have going to close this section, and yeah, at the same time I have my remote. Yeah, at the same time I have my remote PXE boot. I have my PXE boot set up already in my lab. Okay, these are I'm just going to show the list of my applications. These are my applications, as you can see. And of course, I have MSI. This is my EVNG is just an MSI file, and of course you can see successfully deployed. And of course my Node++ is an exe file, so I've had to do the enter the details manually, and they have been deployed specifically to certain users and to certain targeted PCs as well. And as you can see, if I go to my general tags, so if I go into my operating system, you can see if I go into my operating system images, yeah, I've got Windows 10 Evaluation Pro, and this is what allows me to set up a PXE boot, as you can see, successfully deployed. So even though I have my MECM running inside of my site 02, I can easily go into my site number 1, and I have a Windows 10 device here that I can easily just start the Windows 10 device, and of course it's going to search over the network and see if you can find a boot environment. Now it takes some time before it's able to the initial process shouldn't really take too much. As you can see, okay, now we have a boot manager, and as you can see, the IP address of my server is 172.16.10.10, and yeah, PXE. Okay, ideally I should be faster than that in terms of my selecting the choice of IP, otherwise it's going to a timeout. So if I start again, when it gives me the prompt of which server to use, it times out if I don't press the prompt on time. So if I start again and I say top, I'm going to go to this PC that gives me a clear overview of my device, and I say okay, start my PC. Let's get interesting, and I'm going to do escape just to make it start a boot. Yeah, there's a little bit of start, so sometimes it's due to okay, yeah, so I've got I'm just gonna do the boot manager straight, and I'm going to select my PXE IPv4, and now it should be able to give me yeah, it should be able to select IPv4, and now that's an IP address issue, because I've got only 2 IP address left within my ProXmox. So if I just go into my ProXmox and I say if I stop my DHCP service and I just remove my leases, because I've got very limited IP address because I'm using a /28, and I start my DHCP server again. So if we go back into the PC and I stop this PC now, okay, escape, reset, yeah, I stop the PC now, we're starting the PC now. So ideally we should be able to get an IP address at this point and be able to select the server that's to provide our operating system to boot in with. So at this time now we can enter, and I'm going to press waiting for approval, enter again, it's connecting to the server, and as you can see it's loading the operating system file. So now it takes some time, so I'm not going to bore you with the operation, but as you can see it's 172.16.10.10, that's where the boot file is coming from. And if I go into my MECM and I do ncpa.cpl cpa.cpl, okay, we should be able to see that is the IP address of our interface. It's quite slow because I'm only using one core CPU, so sorry about that. So IP config, you can see our PC is 10.10.16.10. that's where we're getting our the operations coming from. Now I have some task sequence as well that's been created, so that at the prompt as the operation is going on, we get a prompt that tells us to input the PC input the PC name, the choice PC name, so we can automatically join it to our active directory once it's done. Now, aside from that one, let's talk about the replication and backup of this PC that's going on into my NAS. If I talk about my NAS now, if I log in into my NAS, you see that we have root. Yeah, into my NAS now, and I go into, and my NAS as well is particularly joined to my domain. So if I go into directory services, active directory, you can see we have joined to hub.local, and of course if I go into my storage, my pools, you can see I have multiple pools. I've got a pool for my home folder, for my ISCSI storage, for my Hyper-V virtual machines, and I've got Tokyo shared storage for all the branches, and I've got a particular pool that backs up my MECM operations. I've recently created this pool, so not so much backup is being done at this time, because I've only got one core CPU, and it's going to be a lot of trouble if I try that. But if I just go into my domain controller and show you what's going on, within my domain controller, I've got a lot of operations going on as well, because these two domain controller, as you can see, between site 1 and site 2, they have a direct connection, and it helps them to replicate operations. Because if I go to domain controller 2 and I just open my DHCP server, sorry about that, if I open my DHCP server, you see that if I go to my DHCP properties failover, you can see that the failover for this DHCP is DC01. That's the failover. If I go to my DC01 and I do something similar, you will see that the failover is a DC02, as you can see, for this particular PC. So it's well replicated and the load is balanced. So DHCP replication aside, on my DC02, I've got DFS replication as well, because on this PC we've got a particular folder that actually stores the I've configured a roaming profile for the user specifically. So if I open my Active Directory users and computers, you will see that we have Active Directory users and computers. Now we'll see that we have my users. If I go to my user group, user organization unit, if I just pick any user, if we go into the profile, you see that we have the profile path setting that has been set, and there's a path for home folder as well. So these folders are created here, and as you can see, each person have their own folder. And of course, we have this folder is created automatically with PowerShell script. If I go into my GitHub, we'll see Windows administration, and we'll see auto user profile creation. So no, it's not this one. This is for my basic creation initially, but this is what invokes my home folder script. So quite a short script, but very powerful, makes my life easy. And I've got my profile as well, my roaming profile for my users, and as you can see, they've got profile, and this profile is replicated as a backup to domain controller 1. So if I go to domain controller 1, you can see we have something similar, and this is done with DFS replication. So if I just go into my DFS replication, you can see this is hybrid up, and these two folders have been replicated to this DC01 PC. And this second folder as well is equally been replicated as well. And at the same time, this domain controller itself is being backed up. So if I go into my shared folder on my NAS, if I go into my network storage, and I say true NAS, I go into I've got my MECM backup going on, but it's not really done much at the moment. But if I go into my other folder, the state backup of my server, I've got another. This was the folder I'd initially wanted to use for my MECM backup before I created its own pool. So if I just go to my Windows image server DC01, you can see I've got my backup operation going on. And if I go into my tools, Windows Server Backup, we can see that once the backup operation loads up, we can see some backups are failed because it's a lab. It's not always on all the time. So some backups are, so you can see the path to the backup. It says states backup, and that is the path we have on my SCCM folder where I have the backup images stored. Yeah, so that's just about the backup. Now in terms of the site replication, because I've got 2 sites, and in each of the sites, more like technically I've got 3 sites. So this is one site, this is another site, and within Proxmox is another site, because even all the Docker managers on my PC, they're joined to my domain controller. So if I show my domain controller, if I show my PCs specifically, we'll see that the PCs are okay. If I just show my computers here, my organization unit, I go to my branch, let's say Tokyo, my local servers, my Linux servers, you can see they are joined to my domain. My Windows server, they are joined to my domain. My clustered nodes, my SQL node, clustered, they're joined to my domain. My IIS server is joined to my domain. That's my it's joined to my domain. That's the IIS cluster anyways. So because they are joined, we know the delicacy of this PC, and that's why this domain controller is being replicated and backed up as well. So if I go into my, let's say I just open my group policy on domain controller 1, group policy on domain controller 2 as well, and I just open Active Directory, let's say sites and services here, and I open Active Directory, my Active Directory sites and services here, you can see on my whichever one is open first, you see that we have multiple sites. Now we have a site 01 hybrid be site 02, and the Proxmox is a site 01, and of course within the site I've got subnets, and you can see I've got subnetworks, and each of the subnet has been assigned to their relevant sites. Their relevant this is assigned to site 02 because it's within the EVNG site. So this PC are assigned, and this is site 01, particularly assigned to site 01, so that any PC within this subnet is assigned to my Proxmox site. So, and that is how the replication is being done effectively, so that if I, let's say for instance, I create if I create a GPO, I just say let's just create a funny GPO, new TTTTT. Okay, just let's just give it a name. Let's say London GPO, which is of course very cool. I've created a London GPO. If I go to my domain controller 02 and I go to my Active Directory, all I've got to do sometimes is to maybe just do a refresh, and I've got London here as well. As you can see, it's replicating in real time. And I've got my Active Directory. I've got a bunch of group policies that makes my life easy, mostly to bypass the firewall and the passwords and so many things, so that I can have easy access within the labs, not necessarily the restriction of users. However, in terms of deploying clients and applications to end users, I tend to use the file group policies to actually create. So if I go into my PC, as you can see now, our 7-zip is installed now because I switched off this device here. So if I switch this one off and I switch this one back on, the operation should be successful as well. It's just the latency is due to the business of the lab. So if I go here and I say if I just come here now and I say cmd command prompts, and I do gp results -r, we should be able to see our applied group policies. And as you can see, we have the BG info and we have the NAS mapping. Now if I do my if I access my server here, because I've only recently installed, and if I just do 174/172.16.10.11, they should be able to pull our NAS. And of course I can equally go into my script, my BG info, and just run the BG info itself. And of course the BG info ideally should, I'm gonna cancel that one for now, and I'm gonna run my template, my BG template apply. And ideally the BG template should run itself because I have a GPO that actually runs the BG info, but due to the network glitches, sometimes the copying takes time. If I go to Windows, startup scripts, you can see I have my startup, I have my script that copies the BG info content into the file, and I have a file here that ideally its intention to make read only. You can use the option to import it. Okay, yeah, I think there's a restriction on this user I've used to. Oh, that was not a restriction that's supposed to be, because it works already. Yeah, it was just an initial network glitch, so it works. Error 7 says template BG info access denied. Okay, I'm not able to save, but I'm able to use it. Yeah, it was a read only that I did. I just remembered. So no, don't save. And if you see, you can have my BG info. You can see I've got the PC name Tokyo here. Logon server is DC01, as you can see, because if I go into my because the site is assigned, the IP address is assigned on the domain controller. The IP address, the domain of the IP address is 10.10.40. The IP address of the PC is 10.10.40.6, and if you go to my PC, it's 10.10.40. This subnet is particularly assigned to my DC or site 02, which is the domain controller of the site 02, and that's why we have the PC is assigned to this thing, and it has the gateway address, which is the server. So there's a lot of segregation going on within the network. A lot of segregation going on within the network, and in terms of the operation of the if I go to my research, my rules and features, DFS cleanup, my Azure services. Now in terms of the replication of this service, of this operation to Azure, if I go into my Intune, the Microsoft.com, and I just do ask later, no, stay signed in, no. So if I go into my users, as you can see, I've got my users listed here, and I think this particular user have the license for Intune enrollment. So if I go into my device and I put on this PC, and let's say I just put this one off in a proper way, I just come here, shut down. I'd initially tried co-management, but for some reason I encountered some problem. So I'm guessing it's due to licensing, but I'm still trying to find out how to, because I've actually created, but the problem I have is when it comes to trying to get my AD connects to sync to sync my PCs so I can assign them and co-manage them. It really does not allow me to log in for some reason, which I'm still trying to figure out. So if I switch on the new PC, go to my M device, and the name is Lagos 10 Intune. The PC is loading. As you can see, I'm going to show you the PC is assigned to Intune already, even though I haven't created some kind of policy to actually control the operation. But that's just about the an overview of the entire lab, even though there's a lot still going on in terms of the NAS operation, then particularly about my Docker, my Linux operation going on, which is a very interesting aspect of administration. I mean, Linux is cool, so yeah. And in terms of the documentation, I'm still trying to perfect the documentation. I'm trying to perfect the documentation, but at the moment in my GitHub, I've got that's taking time to load because I have how many pieces. This one is off, this one is just this one, so it should come on very soon. And I'd see, yeah, I've got the documentation going on with me, just a few overview of what the lab is all about, and what I'm up to particularly, and yeah, what I'm up to: GPU, RBAC, yeah, Intel ZTI, and yeah, that's just about it for now at this time. And I've got other projects as well if you want to go through to see my ability to do a few other things. And I'm just going to make one more reference to my CV, and of course this CV is going live very soon. So hybridhub.local is going to be hybridhub.live very soon, so I can have this live and share as well as much as I can to make my services to create service awareness. So yeah, I should say thank you for your time at this point, and thank you very much for listening. And yeah, that should be it. Our PC is still loading. Thank you.